Friends, welcome back. In the previous session, we have seen symmetry conditions for a wave. So in the symmetry conditions, we have seen what is the even signal, what is the odd signal, what is the half wave symmetry, what is the hidden symmetry. These kind of things we have seen. So in that half wave symmetry, so it is a little bit complicated. That is, we have to check a full wave. That means full period. In that first half period and next half period has to be same with opposite sign. That is nothing but half wave symmetry. Suppose if a wave is exhibiting half wave symmetry, it contains only odd harmonics. Next, we have seen hidden symmetry. In the hidden symmetry, that is whenever if you manipulate the DC value, then we can see that hidden symmetry part, and we have seen that also. Now let's see some questions based on this symmetry conditions which are given in the previous GATE examination. Let's take the question number 6. They have given question number 6. This is the wave they have given. The trigonometric Fourier series contains the trigonometric Fourier series contains option A, odd cosine terms with 0 DC, odd cosine terms with positive DC, odd cosine terms with negative DC. Option D, all cosine terms with a negative DC. So let's see this question and let me know which option is going to be correct for this way. Okay, try to understand. First of all, if I manipulate DC value, so suppose if I change this or if I add let's say a by 2, then it is going to be a by 2 and minus a by 2. Then it is going to be even and half wave symmetry. So by manipulating a DC value means it is having hidden symmetry. So it is having hidden symmetry. In that hidden symmetry, what we are having? Even plus half wave. Even plus half wave symmetry. If it is a even plus half wave symmetry with hidden, then what is the first thing we have to observe? Even plus half wave means it is having only odd cosine terms. Next we have to see what is the DC value. So to see the DC value, just we have to go for the directly the given wave. So I already told you DC value is calculated from the given wave and harmonics are calculated from the manipulated wave. That's what. Okay. So here if you observe carefully, this is the positive area and this is the negative area. Which one looks big? Definitely negative area is more because it is a minus 2a and this is a. So if negative area is more, if you find the DC value, that is going to come as a negative. So A0 is negative. A0 is negative. So in the way, if I say what is that exact value is, suppose let's say this is a T by 2 and this is also T by 2. Then how much is the A0 value? a into t by 2 minus 2a into t by 2 by total period t. So this is going to be a by 2 minus a, that is minus a by 2 minus a by 2. So this is the what is called as a DC value, which is a negative. Remember, this is negative, DC value negative. So finally I can say, because of this half wave symmetry, it is having only odd harmonics. Because it is even, it is having only odd cosine terms. That means odd cosine terms with a negative DC. Odd cosine terms with a negative DC. With negative DC. This is what we have. Question number 7. The non-zero terms of trigonometric Fourier series are, the non-zero terms of trigonometric Fourier series are options a0 and bn. a0 and bn, where n is equal to 1, 3, 5 and so on infinity. Option B, an and bn, for n is equal to 1, 2, 3, 4 and so on infinity. Option C, a0, an and bn, n is equal to 1, 2, 3, 4 and so on infinity. Option D, a0 and an, where n is equal to 1, 3, 5 and so on infinity. Which option is going to be correct? First we have to see what symmetry it is having, which symmetry it is having. So if you don't know the what is hidden symmetry, then definitely everybody will go for this option, option C. Because so it may look like, okay, it is having even symmetry, so definitely so which one is 0? If it is even symmetry, bn value is 0, so we are having only an. So maybe they will go into different option, but option D is correct. Why? It is having hidden symmetry. Suppose if you change the DC value, then you are going to see the hidden symmetry, and it is having even symmetry. Hidden, in that hidden symmetry, in that hidden we are having even plus half wave. Even plus half wave. So even plus half wave with hidden symmetry, definitely it must have the a0 value, and because it is a even, so we are having a0 and an only for odd values of n. An is present only for odd values of n because of this half wave symmetry. Clear? Question number 8. If x of t is equal to signum cos t, then What are the trigonometric Fourier series contains? Trigonometric Fourier series contains. Options. Fourier series does not exist. Fourier series does not exist. Option B. Odd cosine terms. Option C. Odd sine terms. Option D. All sine terms. All sine terms. Which one is going to be the correct answer? So many people think that Fourier series does not exist, but it is not the case. So signum cos t is a periodic wave. How, sir? Let's check it out. First, try to understand what is signum function. Signum function is going to be 1 or minus 1 depending on what is the argument. So that means inside bracket. If inside bracket value is a positive, then we are going to get the signum function is 1. If argument is going to be the negative value, then signum function is going to be the minus 1. So these are the things what we know. So that's what we have seen in the signum t function. T is positive, then it is 1. T is negative, then it is minus 1. So the same thing can be applied for the argument. That means the entire bracket, inside bracket term. Okay. So inside bracket term, if it is positive, its value is going to 1. If it's negative, its value is going to be minus 1. So first draw the cos t, how it is going to look like. Minus pi by 2, pi by 2, 3 pi by 2, minus 3 pi by 2, like that. So minus pi by 2 to pi by 2, cos t value is positive. So signum function value is 1. So if I draw the signum cos t, then minus pi by 2 to plus pi by 2, its value is 1. And pi by 2 to 3 pi by 2, its value is equal to minus 1. It will keep on go like this. One minus 1, 3 pi by 2, like that. So you tell me, what is this function, what kind of symmetry it is exhibiting? It is having even symmetry as well as half wave symmetry. It is not hidden. It is actually directly even plus half wave symmetry. It contains even plus half wave. If it is even plus half wave, then what kind of terms it is having? Even means only cos terms, half wave means that too only odd cosine terms. So odd cosine terms. This is what the option is. Try for homework. You can do this. Let's say x of t is equal to signum sin t. Try this one. And x of t is equal to u of cos t. In the same way, x of t is equal to u of sin t. These three you can try it at home. Signum sin t, u of cos t and u of sin t. Okay. Take it. Which is a polar form of Fourier series. So what is a polar form of Fourier series? This is also called as amplitude angle or magnitude angle. form of Fourier series. Magnitude and angle form of Fourier series. So we know in trigonometric Fourier series, what is the trigonometric Fourier series? X of t is equal to a naught plus summation n is equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. This is what we know. Now this can be converted like this also, a0 plus summation n is equal to 1 to infinity root of an square plus bn square cos n omega naught t minus tan inverse bn by an. So in this form also we can write it. Okay. So this is nothing but the polar form of Fourier series, which is x of t is equal to, this a0 can be represented as capital A0 plus summation n is equal to 1 to infinity. This root of an square plus bn square is represented as capital An cos n omega naught t plus phi n. So where what is the an value? Where an is nothing but root of an square plus bn square. And similarly, what is phi n? Minus tan inverse bn by an. So these are the things what you have to remember about the polar form of Fourier series. So this is what the polar form of Fourier series. Clear? So here if you observe carefully what the polar form of Fourier series is going to give you. So this is nothing but the amplitude or magnitude we can say, and this is nothing but phi n, which is nothing but phase. So whenever you want to find out at any harmonic, let's say nth harmonic, for nth harmonic what is the amplitude? That is nothing but an. What is the phase? Phi n. That's what the meaning of it. I hope you understood. So whenever, suppose let's say I want to go for the fifth harmonic, then what is the fifth harmonic amplitude? That is nothing but capital A5. What is the fifth harmonic phase? That is nothing but phi 5. So that's what the meaning of it. So remember, it's always about the cos. It is always about the cos wave. So for cos wave, how much is the amplitude? For cos wave, how much is the phase? These are the things what we have to observe. Clear? So by using this, we can develop a concept which is called as spectrum. What is the spectrum? We will see. First take down this, then we will see the what do you mean by spectrum. Spectrum. You might wonder what is a spectrum. It is nothing. So actually, if you represent a signal in the frequency domain, or if you represent a signal with respect to frequency, then that is nothing but the spectrum. So it's simply frequency representation. That's only the thing. So what is a spectrum? Frequency domain representation. Frequency domain representation of a signal. Frequency domain representation of a signal. That's what the spectrum. So whenever spectrum, so it doesn't make any difference. That means if you represent in the time domain, if you represent in the frequency domain, it won't make any difference. The same two what we can say representation or two graphs are going to give you the same information. So a signal can be represented in time domain, a signal can be represented in the frequency domain. So it's the same signal. So finally the information whatever it is giving in the time domain, the information whatever it is giving in the frequency domain, exactly the same. That's what the meaning of it, even though the graphs looks different. So whenever I say spectrum, it is having internally two more spectrums, means two more representations. So spectrum is of two types. One is called as magnitude spectrum. magnitude spectrum, and another one is a phase spectrum. Phase spectrum. That means, so in this Fourier series, we are having an versus n omega naught. An versus n omega naught, which is nothing but the magnitude spectrum. Whereas phase spectrum is phi n versus n omega naught. Phi n versus n omega naught. These are the phase spectrums. So let me give you a small example so that you can understand what is a spectrum. Suppose if x of t is given like this, x of t is equal to 10 plus 8 cos, let's say 5t plus 30 degrees plus, let's say 5 cos 10t plus, or we can say minus 45 degrees, like this. So if this is the wave, then how we can represent the spectrum? So I told you we are having the magnitude spectrum and phase spectrum. So from that, let's see, what is the magnitude spectrum? An versus n omega naught versus n omega naught. Whereas phase spectrum, which is phi n versus n omega naught. Phi n versus n omega naught. So what are the frequencies we are having? They are first 0 frequency, next frequency 5, next frequency 10. These are the frequencies what we are having in the waveform. So now let's say, what is the magnitude waveform? At 0 frequency, how much is the magnitude? That is nothing but 10. What is the phase of it? No, it is not having any phase, which is nothing but 0 phase. So if I represent that, it is 10 and 0 phase. Magnitude is 10 and phase is 0. Next, at a frequency 5, what is the magnitude? 8. What is the phase? 30 degrees. So it is having magnitude is equal to 8 and phase is equal to 30 degrees. Phase is equal to 30 degrees. At frequency 10, what is the magnitude? 5. What is the phase? Minus 45 degrees. Minus 45 degrees. So this is called as spectrum. So the same thing. So I can say the same thing can be represented with respect to frequency. Is it giving the exactly the same information what the x of t is giving you? Yes. See here, I already told you whenever spectrum means it is always about the cos wave. So here 0 degrees means it is not a cos wave, it is directly a DC value, which is nothing but 10 with the phase is equal to 0. Next, at frequency 5, we are having 8 is the amplitude and phase is the 30 degrees. Suppose if I want to, without saying this, can you write the wave? Can you write the expression for it? Cos 5t. So it is having magnitude is equal to 8 and phase is equal to 30 degrees. So 8 cos 5t plus 30 degrees. Next, at 10 we are having a cos wave, which is nothing but cos 10t. Then what is the waveform for this? Because it is having a magnitude 5 and the angle is equal to minus 45 degrees. So we can write cos 10t is having magnitude 5. That is nothing but 5 cos 10t minus 45 degrees. So I told you the same information can be preserved in the spectrum also. So spectrum also is going to give you the same information whatever it is giving you now. Clear or not? Okay, take it. So this is nothing but the spectrum. And one more thing here I want to say, spectrum, that too Fourier series spectrum, if you observe, it is always line spectrum. That means it is not a continuous spectrum. Why? So because we are considering the harmonics. If I considering the harmonics, they are nothing but discrete only. That means let's say 10, suppose 5 is there, next has to be 10, next has to be 15, like that. So it is nothing but n omega naught. N omega naught means n is a integer. Definitely, if n is a integer, first let's say omega naught, 2 omega naught, 3 omega naught, 4 omega naught, like that. So we don't have the continuous frequencies. So I can say this is a line spectrum or discrete spectrum. So it is a line spectrum or discrete spectrum. Line spectrum or discrete spectrum. Discrete spectrum. And one more thing you have to observe, magnitude spectrum is always positive. Phase spectrum may be positive, may be negative. It can take both positive as well as negative values. So you can say here magnitude spectrum is always positive. Phase spectrum may be positive, may be negative. May be negative. It can take both positive as well as negative values. Okay, take it. Thing which is given like this. Let's say 4 minus 8 cos 10t plus 10 degrees. 10 degrees. It is given like this. I already told you magnitude is always positive. Then what we have to do with this negative sign? Then we have to bring this negative sign into the phase. So if I take the negative sign into the phase, that is going to be plus or minus 180 degrees. So 4, let's say, plus 8 cos 10t. So if I say minus 180, so it is going to be plus 10 degrees plus or minus 180 degrees we have to make. So it's your convenient. You can take plus, you can take minus. It won't make any difference. Both are same things. Okay, take it. So this is the way we have to convert a negative sign into plus or minus 180 degrees. Okay. So I hope you understood what is a spectrum. So it is having both magnitude as well as phase spectrum. Next, give a heading which is very, very important one. Fourier series coefficients for symmetrical square wave. For symmetrical square wave. Symmetrical square wave. So it's only for symmetrical square wave, not any other wave. That means it may be even symmetry or odd symmetry. That means even or odd only. Even or odd. For these kind of symmetries only we can create this one. This is the formula. Okay, let's see what is this. So first write down this point so that I can explain it later. First point, find DC value from original waveform. From original waveform. What is the DC value actually? That is A0. DC value means A0. DC value means A0. Next, determine non-zero coefficient. Why? Because I told you this, whatever the formulas we are applying, it is valid only for even or odd symmetry. That means if it is a even symmetry, definitely Bn value is equal to 0. If odd symmetry, An value is equal to 0. So we are having for even symmetry, what is a non-zero? That is nothing but An. For odd symmetry, we are having a non-zero, which is nothing but Bn. I hope you understood. So that's what we have to determine. Once it is an or bn, both are having the same formula, an or bn, which is equal to 2 into maximum value minus minimum value by n pi. What do you mean by that? So these are the 2 points you have to remember. Suppose a wave which is given like this. A minus A 0. So what kind of symmetry it is exhibiting? It is exhibiting odd plus half wave symmetry. It is exhibiting odd plus half wave symmetry. If it is exhibiting odd plus half wave symmetry, let's see what are the 0 values. A0 is equal to 0, an is equal to 0, bn not equal to 0 for odd values of n. For odd values of n. So this is the non-zero. So from this formula, bn value, if I calculate, what is the bn value directly? 2 into, what is the maximum value? A minus, what is the minimum value? Minus A. So minus of minus, that is going to be plus A by n pi. So this is going to be 4A by n pi for odd values of n. For odd values of n. So this is the formula you have to remember. Then how we can write this x of t expression? What is the expression for x of t? So if I write the expression for x of t is equal to we don't have any constant value because a0 is equal to 0. We are having only bn, that means odd cosine terms only we have to write. So if it is an odd cosine term, first one 4a by n pi. So in that odd value of n if I take, then it is going to be 1 pi. So 4a by pi sine omega naught t plus next odd harmonic, that is nothing but 4a by 3 pi sine omega naught t plus 4a by 5 pi sine, this is 3 omega naught t, third harmonic, right? 5 omega naught t plus and so on. So this is the way we can write directly the expression. Clear? First take down this. Then we are having some complications with this one. So how to overcome those complications also we can see. First take down this. Note. Note 1. First point. If there exists jump at t is equal to 0. If there exists jump at t is equal to 0, that implies all the terms have same sign. All the terms have same sign. That means maybe positive sign or maybe negative sign. That means suppose in that one again, if positive jump, then all are positive. Second one, if negative jump, all are negative. Second point, if there is no jump, if there is no jump at t equal to 0, then alternate sign. alternate sign. What do you mean by alternate sign? Positive amplitude at t equal to 0. That implies alternate sign will be like this, plus minus plus minus plus minus plus, like that, and so on it will go. Suppose if it is a negative amplitude, at t equal to 0, that implies alternate sign is like this, minus plus minus plus minus plus, and so on, like this. It will go like that. So first try to understand. Suppose I have already taken an example. Okay. So at t equal to 0, we are having a jump. At t equal to 0, we are having a jump. That too, it is a positive jump. That too, it is a positive jump. Positive jump. If it is a positive jump, then how to write the x of t expression? How to write the x of t expression? And we know that it is having only bn. Bn is equal to 4a by n pi. 4a by n pi. So we are having only sign terms. Then x of t is having all are positive signs. Just now we have written that 4a by pi sine omega naught t plus 4a by 3 pi sine 3 omega naught t plus, and so on, like that. Suppose if it is having negative jump, that means minus a to plus a means it is a positive jump. What if it is a negative jump? How it is going to look like? Negative jump means zero, a minus a. So if you observe carefully, this is jumping from a to minus a. So it is also exhibiting odd symmetry and half wave symmetry. So it is also having only bn. What is bn value again? Bn is equal to 4a by n pi only. But only the thing is, while we are writing the expression, we have to take everything as a negative value. So that means if it is having a negative jump, so all are having the negative. So all are negative. That means everything we have to write in the negative terms. That means x of t is equal to minus 4a by pi sine omega naught t minus 4a by 3 pi sine 3 omega naught t minus, and so on. Like that we have to write. First take down this, then we will see that second point also. Suppose let's take a wave which is in this manner. A minus a 0. So we don't have the jump at 0. So we don't have any jump at 0, but we are having a constant amplitude which is positive value. So I say no jump with a positive amplitude. So it is having positive amplitude. Now what kind of symmetry it is exhibiting? Even plus half wave. Even plus half wave. Then it is having an value. Then what is that an value, which is same as this one, 4a by n pi. That is 2 into maximum value minus minimum value. So again the same thing for odd values of n. So now we have to write the cos, but we have to see it is an alternate signs. What do you mean by alternate signs? While I am writing x of t, 4a by pi cos omega naught t minus alternate sign 4a by 3 pi cos 3 omega naught t plus 4a by 5 pi cos 5 omega naught t minus 4a by 7 pi cos 7 omega naught plus and so on. So I hope you understood what is meant by alternate sign. Clear? In the similar manner, suppose we are having a waveform which is like this, which is having a negative amplitude with no jump. So if you observe carefully, at 0 we are having minus a. At 0 we are having minus a. Then what kind of symmetry it is exhibiting? So it is a negative amplitude at 0. It is also even plus half a only. So it is also having an is equal to 4a by n pi. Then we have to write the alternate sign in this manner. That means x of t is equal to minus 4a by pi cos omega naught t plus 4a by 3 pi cos 3 omega naught t minus 4a by 5 pi cos 5 omega naught t plus and so on. So alternate sign here also, but only the thing is minus plus like that. But here also alternating sign plus minus plus minus. I hope you understood. So if you remember them, then it is easy to write any equation if it is a even square wave or odd square wave. So there are four waveforms, even in the odd. So these are the four waveforms you have to remember. Clear? Take down. If you remember them while we are doing the questions, it is